-1s. Welcome back to the last part of this lesson. There's just the three graphs we're going to do here. They're a little bit more important because of the way the divide part works out. But let's just say, let's just start off with the easy one here. We're just going to multiply these two out. So that's what that means. So remember that when you see f times g of x like this, you can say f of x times g of x, which is the same as saying one y value times another y value. So I'm just going to multiply these two y values. The fun thing about this is that these are both linear equations here. When you multiply two linear lines out, you're essentially just multiplying. I can actually create the equation for these, and we look at this as well and see what it actually will turn into. So the equation for g of x here, I thought maybe it would give me a little click here. No, well, let me do it. Okay, so the equation of g of x, we're going to start off with here. If I make it into the form y is equal to mx plus b, the slope is 1 over 3 x plus 1. So that's g of x. And then f of x, if I do the next one for f of x, its slope is -1. It looks like it's going down 1 over 1, yep. -1x minus 4. Now my new graph h of x is just going to be these two things multiplied together. You can see that what's going to happen is that when you multiply these two linear lines together, we're going to get a quadratic out of this. So you get -1/3 x squared, and then we get a bunch of other stuff here, and then we get a -4 down here. Okay. Yeah, seems pretty good. So it's going to be a quadratic. It's going to be a negative quadratic, so it's going to be opening downwards. I can see my constant value here is -4, so that's my y-intercept. And you can see that from here, if I multiply my y values, 1 times -4, I'm going to get -4 for one of my dots. Here I have 0 times -1, so I'm going to get 0 for one of my dots. Right? And we just keep on going through, and we just multiply y values. So let's start over here at the very back here, at -6, 7, 8, -8 here. We got 4 times, oh, that's not a very good one. Let's go with this one up here. 5 times -2 will give me -10. That's beyond my graph. This is the next one I can read. I can read at -6 here. So I got -1 times 2, so that gives me -2. So I kind of have this kind of shape. I have a point way down here. I got some other points. Let's keep on going here. Let's see what else we have. Ooh, we have a 0 times something, so there's going to be another 0 right there. So it looks like I'm going to go up and down through this point here somewhere. Now let's see what additional points I have. Here I got a 2 times a -7. That would give me like a -14. That's beyond my graph at this point. Here we got two negative numbers, two negative like quarters or something. So they're going to be up here somewhere. Oh, here's a 1. 1 times anything is going to be the same number, so that's going to be that. So there's an invariant point there. So it kind of looks like this so far. That's why that's a 1 down there. That's what I'm going to assume this graph looks like. It looks something like that. That's pretty good. Okay. Determining certain things like what's my domain of this graph is going to be a bit trickier to try to determine what that is. You'd have to kind of know where this point is right here. Where is that point? I don't know exactly where that is, but I do know the domain of both of these graphs before we start. This is XER. Domain of this graph is XER, which also means the domain of my new graph is also XER. My range is YER, which is a linear line. And my range here is going to be YER as well, which is a linear line. But my range for this graph is not going to be YER. It's going to be some value Y less than that value. Now I could, because I created the equations here, I can load up my calculator and actually find out what that point is. So maybe I'll do that. Let's see what we can get out of this. So we know, I'm doing the multiplication one here. I'm just saying multiplication. We have a 1/3 x. What was it? 1/3 x 1/3 x plus 1. That one. And then I had a negative x minus, what did I say it was, minus 4. My head out of the way here, minus 4. Yeah. Minus 4. Okay, so I'm going to graph all those. So these are the lines that we have. They look very similar. Here's my graph that looked like what we drew. I want to know what the max point of this black graph is right here. This looks like the maximum, somewhere right about that point right there. Is it halfway between these two dots? I don't know. So what we're going to do is we're going to go second trace. We're going to do maximum. Because I have more than one graph, I have to decide which graph I want to do the maximum of. So I'm going to hit the up and down arrow here until I'm on my graph that I'm worried about. And then I'm going to go do left, right, and then we're going to guess here, somewhere up here somewhere. Yeah, so it looks like a maximum is actually somewhere halfway between the 2 points, which is nice. And I have a maximum value of 0.083 repeating. Now I just want to see what value that is as a fraction. It might be easier to do as a fraction. So what we can do here, pull up my y value. There's my point there. So whenever you do any calculations in the graph, it automatically stores the x and y's for you. And then go math, enter, enter. So it's 1/12. Okay. Well, let's go back to my equation. Okay, here we go. So here I have 1/12. Cool. Looking good. Okay, so the next one here, the reason I wanted the next one is so that when we divide, if I am to divide by f here, because this will just be g of x divided by f of x, this cannot be 0. I'm not allowed to have that to be 0 on the bottom because I have to divide by error, divide by 0 error. So when I'm plotting this out, I have to look for those pieces. So I'm dividing by f right about here. 0 divided by 0. I'm going to have some problems right here, right? Otherwise, that's just fine. I think on my next graph, you can see that I have another point where I'm dividing, so I might have to divide by 0. But here I'm dividing by f. So I'm taking g. Let's say I take this g1 right here. I find some good points, like here's a point. Pick that point there. I'm going to divide it by this point way down here. So I'm just going to divide those two numbers. The two numbers are the same, like this point right here. So this number divided by itself, the y value, ends up being 1. So that point's going to be up to 1. Okay? I'm taking a quadratic and dividing by a linear line. So I'm taking something that's x squared, blah, 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 and dividing by a linear line. I might assume that this is going to be linear to come out. Well, hopefully it does, because you're kind of like factoring out. So I'm taking this point here, 4. Taking a y is equal to 4. So I take this point, I'm going to divide it by this point. 4 divided by negative 4. Oh, that's nice. Got negative 1. Okay, so I'm taking g of x. So this is 0 at this point right here. 0 divided by anything is going to be 0. So right now I have 3 points right here. It looked pretty linear there. Let's find some other points that we're going to do here. I don't have any other good points on that side. I don't know if I can make the assumption it's going to be linear on this side or not. We could do these 2 points here. We could do this point. So g of x is the blue one. So I'm going to take that, negative 6. I'm going to divide it by negative 2. 3. Right there. Okay, looking pretty linear actually. It looks like 2 up, 1 over, 2 up, 1 over. Let's try another one here. Let's try this point here. Let's try this point here. We got negative 5. I'm going to divide it by. What am I going to divide by here? I'm going to divide by negative 1. I don't know why I was thinking about that one so long there. So that turns out to be a 5. So that's nice. So that's another straight part of the graph right there. Something's going to happen here. Don't know what's going to happen there. I'm just going to go right to the next point. There's another point I can do here. Looks like this 9 divided by 1 will end up being 9. So there's a point right there. So I have a graph that looks like this. Now, what happens here is that there's a point of discontinuity again. There's a hole here. Now, the reason behind that is because you're dividing by something. So you have this quadratic here. I don't care what it really is. The bottom line, I know what the equation is. I can determine that pretty easily. It's x minus 3. Yeah, x minus 3. So I have a non-permissible value when x cannot be 3. So I need a hole. I had to include that in my final answer. Whatever this final answer happens to be, x cannot be 3. If I were to put that back into this final answer, I'd probably get this equation up here. Right? So it does look like it's going to continue being a nice linear line. It's going to continue down in both directions forever. Looking good. So we do have a hole in this graph that we do have to worry about. If you want to, you can actually try to figure out what the equation of this line actually ends up being. I'm not too concerned about that. And so f of x, where is f of x? F of x is the orange line that we divided by. F of x is the nice linear line, so is a domain and range of xer and yer. Okay, my g of x is a quadratic, so my domain is going to be xer. My range is going to be whatever this min point happens to be higher. I'm just going to say it's approximately. I'm not going to bother trying to graph that out. So it's approximately greater than or equal to, I don't know, 6 point something. Let's just say 6-ish. Okay. It's going to be 6-ish. Okay, so not exactly 6. Not too worried about that at that point. I'm just worried about this hole in this graph that comes up here. Let's see what else we have here. Oh yeah, domain. Okay, so our domain of this graph, because we're dividing by f of x, and f of x has a 0 on it, my domain has to include that piece now. And because of that point of discontinuity, my range also has a hole in it at, looks like it's going to be 7. Yeah. Yeah, I could probably hazard a guess what the top would be, because I can use the two lines that I created here to create two equations. So maybe I'll just do that right now, just to figure out what these two lines could be. So you already knew what f of x was. F of x here is x minus 3. And this other line here, the one that we just created, has a slope of 2x plus 1. So whatever, so if I were to multiply this up to the other side, whatever x minus 3 times 2x plus 1 is probably whatever that quadratic is, 2x squared. There's going to be minus 3 here, negative 6 plus 1, negative 5. Oh! Okay. So that's what this equation would be. So this is g of x here. There you go. You can look at that, you can graph that to find out what the min point happened to be if you need to. Okay, so our next one here, we're going to take our f of x and we're going to divide it by g of x this time. So f of x is this orange line that I have here. G of x is the one that has the negative slope to it. So we're going to divide our y values this time. We're going to go f divided by g. So let's look at some key points here, like these 2 points are exactly the same. So when I divide them, they end up being the same. Let's put that point right there. Okay, so they end up, it ends up being 1. All right, so that point just kind of drops down just a little bit. Here, I'm going to run into a problem. I have a number divided by 0. So this number here and this, I'm divided by 0. So at this point, I'm going to have a point or asymptote here. I'm not allowed to divide by 0. It's not going to be a point of discontinuity like the last one where the zeros matched up. So I actually have a point of discontinuity, or an asymptote here at 2. So I'm divided by 0. I can go the other way though. 0 divided by anything. So this point here is going to be 0. So I'm going to have it's going to have to go through here and have a little asymptote. It's going to go kind of like this. Kind of like something like that. I think that's approximately what it would be. Yeah, around there. Now, you see there's another point in there, so maybe I'll just kind of erase this. I'll show you where this other point is. Okay. So we have this asymptote. I'm going to just draw that asymptote back in there. No. Oh, no. What just happened? No. Okay, there we go. Okay, so we had 1 right here. We have 0 right there, and then we'll have this point right there. Kind of hard to see with my rainbow pen. The reason this point right here is here because that's going to be that number, which is f of x divided by 1. So that number doesn't change. So I'm going to go through those 3 points, and then it's going to go up towards this asymptote right there. Then we're going to see what happens on the other side of this graph here. So I'm going to keep on dividing by g of x, and g of x is getting larger and larger and larger. My f of x is not getting that large, but let's see what happens. So we have a 1 divided by 6. So that's 1/6 right about there. Here we have 2 divided by, what's 2? Negative 2, sorry, divided by 8. 2 divided by 8. It's 0.25. Right about there. Okay. We're going to have 3 divided by, if I extrapolate this a little bit here, what's going to be? It's going to go up by 2. So rather than 8, it'll be 10. So 3 divided by 10, so 0.3. Okay, so my graph is going to kind of level out here. Yeah. Okay. Now I can hazard a guess about where the asymptote actually is. It's probably going to be at 0.5. Okay, we can talk about that later on when we talk about the equation of this, but my asymptote is probably going to be at 1/2. Not going to go back up there. So it's not going to go that far down. We'll talk about how we can estimate that it's going to be at 0.5. On the other side, we're going to do the same thing. We're going to go f of x. So 3 divided by 2. 3 divided by -2. 3 divided by -2, because the blue graph is g of x here. So -1.5. So somewhere right about there. I don't know where this point came from. Okay. Here I'm going to go whatever this number is divided by -1. So that looks like almost 2.5 there. 2.5 right about here. And this is -1 here. So I'm going to go like -2.5, somewhere about here. So you can see that this is going to go downwards towards the asymptote. And this is probably going to go up towards the asymptote this way. There you go. Now the reason that how I know where the asymptote is going to probably be at -1/2 is the 2 lines that we're dividing here. So f of x, this line here, is x. That's all. It's just x. That's all that equation is. That's f of x. And then I'm dividing it by g of x. And g of x is going to be -2, because it's 2x plus 4. So remember our rule that the degrees of both of these are the same. I divide the coefficients between them. If I divide 1 divided by -2, I get -0.5, and that's my horizontal asymptote. Okay, so I know I have a horizontal asymptote. So let's go down here and fill out the bottom of this chart. What do we have here? So this is going to be XER, YER. This is also a linear line, so XER, YER. I don't know if my fan on my computer is actually getting in the way of this, but hopefully you guys can still hear me. And I'm going to go H divided by G. So this one here is going to have a domain restriction of 2. X cannot be 2. Yep. and y cannot be negative a half. Okay, there we go. So that finishes up our lesson. The next lesson that we're going to talk about composition of functions, where we put functions within functions. There's a little opener here, so I want you guys to try this out before we move on to composition functions. It's just kind of the same as what we did. These graphs look pretty similar. Here we're just minusing, times, and dividing. But I'll see you in the next video. Later.